Again, we want to reiterate the point that the actual lens in front of the real printing is completely transparent and essentially invisible. But it is not really feasible for us to discuss with you what we're going to be doing with this lens if the lens is constructed in a manner where you can't see it. And so in order for that problem to go away, we've altered the property of the lens so that you can see what we're talking about. This is the lens with some blue color added to it and some opacity to it, so you can see through it and get how it looks. You'll notice the way SketchUp draws this is this little circle right here is a way of telling you where the bulging out portion of the lens is. And again, this is a convex planar lens. One side of the lens pokes out. The other side of the lens is completely flat. This side is flat. This side pokes out. And this lens, as it is sitting right now, would sit directly onto the printing. But because of the way we want to talk about it, we're going to alter the lens a little bit to continue our discussion of what we're going to do with it. The lines around the lens that are present can be softened by turning on the softening feature of SketchUp. We've also altered the opacity. We've taken it from something that you can see through and converted it into something that is completely opaque. The next thing that we wanted to do, because of the way this lecture is put together, we need to have the part of the lens that bulges out pointing in the other direction. So all we did was flip the lens. So the convex portion of the lens used to be on this side, and now the convex portion of the lens is on that side. And we told SketchUp to change how it portrays the lens to give these lines to it so it's easier to keep up with where everything is. And we've re-added a loss of opacity to make it so you can see through it. We're going to be talking about activities that we do to a particular part of the lens, actually the flat planar side of the lens. And so in order to continue our effort to make this more clear, we're going to alter the colors where we take the periphery of the lens and make it a solid blue color. We take the convex portion of the lens that bulges out and make it a blue color that is a little bit transparent. And we will go on to look at the back of the lens, and in order to keep the two surfaces separate in your mind, we took the back of the lens and made it completely opaque and another color, green. Now, the lens itself is going to sit down onto the printing, and the lens has got to have space in the lens where the parts of the printing that stick out can stick into the lens. And the process that we are proposing to use to do that is to generate depressions in the lens that are depressions where the letters and various structures of the printing can be. And you can see that we have drawn in an object here where the various letters of the printing, a small protrusion for the coloring area, and protrusions for the cross and the other letters are all present in this structure. And we've made this structure this orange-red color because we want it to be completely different from the lens. This structure is going to be made from boron nitride. Boron nitride is a type of ceramic that has several features that we need. One feature is that boron nitride can be 3D printed. In addition, boron nitride is not affected by the temperatures we need to use. The final feature of boron nitride is that boron nitride does not stick to soft or high temperature or nearly molten ceramics or glasses. It has no affinity for them at all.